sorry. Okay, so when you're asked to find the stationary points of the following, so remember the stationary point is when dy dx equals 0. So we first have to find dy dx. So we go off and we find dy dx for this formula. So this one would be 12 minus 4x. So now we know, and the stationary points are when that equals 0. So then we let that equation equal 0, and then we solve for x. So I might have 4x equals 12, x equals 12 divided by 4, so we get x equals 3. So at the graph is stationary at x equals 3. Now because they said find the stationary point, we need the y value as well. So we know it's stationary at x equals 3, so we're going to sub now x equals 3 into the original formula to get the y value. So y will equal 9 plus 12 times 3 minus 2 times 3 squared, and we end up with that being 27. So therefore the stationary point is 3, 27. Okay, so let's do the next one. So obviously the stationary points for this graph when t is above 0. So often these ones are indicating time, so we don't have negative time, so that's probably why they said it. So let's have a look. We need to get dy dx, so we'll get that one. So to be 6t squared minus 10t minus 4, and we get that. And then we're going to let that equal 0, because that's when the stationary points occur. So once now we have a quadratic equation, because it's just a 2, we're letting equal 0. So remember, with quadratic equations, we need to factorize to solve. So let's go and factorize this. Now there's a common factor first of 2. So we're left with 3t squared minus 5t minus 2, and then equals 0. And then I might look at in between brackets if I can factorize that. I might try the cross method. So I could say 3t and t, and then I could use 1 and negative 2, and we can see there we get negative 6t and t. That will add to give that. So I can say this expression factorized is 3t plus 1 and t minus 2 equals 0. So then we can go about it solving. So t could equal negative 1/3, or t could equal 2. But we only want this one because of what they said. They want ones that are greater. So now we know, so when we know t is 2, so we put it back into the original formula, which was this, to get the p value. So p would have been 2 times 2 cubed minus 2 squared minus 4 times 2 plus 13. And we ended up getting p equals 1. So the stationary point for this one is 2, 1. Right. Okay, let's go again. So we want the stationary point for this one, so we need dy dx, which for this one would be 3 minus 3x squared, and we're going to let that equal 0 because the stationary points occur when the derivative, or dy dx, equals 0. And then we're going to go and factorize this. So we'll factorize it. We could have 3 outside, and we get 1 minus x squared. Okay, now underneath there, when we factorize this bracket, that's actually one of the patterns. So you could just quickly factorize this now to be 3, 1 plus x 1 minus x, because that's the difference of perfect squares there. So we end up with x could be plus or minus 1. So then we've got those 2 points. You're going to sub them into the original. So y equals 4 plus 3x minus x cubed. When x equals 1, y equals 4 plus 3 minus 1. So y equals 6. Okay, so that was 1 point is 1, 6. And then you do it again with x equals -1. And we get y equals okay, so we end up with y equals 2. So the other point is -1, 2. So they're the 2 stationary points here. They're the 2 answers are there. Okay, let's have a look at this last question. The curve with the equation y equals x cubed plus ax squared plus by plus c passes through 0, 5 with a stationary point at 2, 7. Find a, b and c. So we know that dy dx equals 0 at 2, 7. Okay, so let's go and work this. So let's find what dy dx is. Even with the letters, if we like, we could say that dy dx is 3x squared plus 2ax plus b. And we know that this is 0, so I could put when x is, so 0 when x is 2. So we can put that in 2 squared plus 2a times 2 plus b.